hard problems in computer science, cache invalidation, and video conference.
And printing. Don't forget about printers.
And printing, yes. And Linux, suspend, resume.
Let me go back to...
All right. Are we in business?
Looks like it.
All right. Welcome, Yousef, and it's all yours.
Nice. Thank you. Excited to be here and talk about TypeCell, which is my journey into creating a block-based rich text document editor that is end-user programmable. Of course, we all know this famous quote by Mark Andreessen, software is eating up the world. And one of my motivations to work on this is, okay, if that is actually happening, maybe we should step back and see what we want that software to look like. It's really great to be here with, I think, many people who share this, this motivation, this mindset. So what does that mean for me? I want to explore what could software look like when you really put users in control. So it's about giving users agency over the software and the tools that they're using. So TypeCell is a fresh take on what that can look like, and I focus on two main things, which is hackability, so end-user programming, etc., to make it possible to tinker with the software that you're using. And as part of that, I also want to make programming easier, because otherwise you can still not really tinker with the software. So, and I try to achieve that by embedding a live, reactive, as-you-type programming environment into the system. It's also built on local-first architecture for a lot of other end-user benefits. I'll talk more about my experience in that tomorrow. Today, I'll start with a quick introduction. We'll look under the hood at how the core engine works. I'll demo some of the different layers of abstraction. I'll put it into context to related work, show some more experimental demos, and then conclude with what I think are the strengths and challenges. Quick demo. Let's see if that also works. Yeah, so basically TypeCell is, you start off in the Notion-like environment, and you get all these blocks that you can use, and it's a rich text and notebook-style programming. So when you're using Notion, or for example, you can only use the blocks that they provide. But here I can also open a code block, define a variable. Hello, live. Everything, as you see, evaluates as you type. You can use TypeScript, JavaScript, React. So I can create another code block, and I can create something simple. I always think it's fun to see that marquees still exist. And using the $sign variable, I can actually access variables from other cells. So now I can just import the greeting, and I get this nice live marquee. But what's even better is when I edit the variable in the other cell, the marquee also automatically live updates. So this is the basic programming model. Of course, if you build upon that, you can do more complex stuff. So for example, build a simple savings calculator, add a slider, all the variables, they bind to the system. This imports Vega Lite, so you can import libraries from NPM, including Confetti, etc., etc. And what's also cool is that I think it's, let's see, which one? Yeah. It retains the liveness across documents. So if I open a different document here, let's see if I can arrange this right. Here we go. So this document now imports the module that I was just editing, and it uses the greeting variable from there. And as I change this, then hopefully the other one should update as well. I might have just restarted my computer, so maybe I didn't start the server that actually propagates. Try to get it for the display, of course. Normally, things live update across this. Let's see. Yeah, well, refreshing is not as live as it should be, but you'll see it in the other demos. All right. So that explains the core system. The fun thing is, or actually maybe a bit disappointing after 2 years of work, is that the core of this can be written in about 30 lines of JavaScript and MobX. So MobX is a framework for a library for reactive programming, makes heavy use of observables. I think nowadays everybody likes to call them signals. It's somewhat similar. And then, let's work on the resolution. Let's see, yeah, here we go. It's too big, right? Yeah, so you basically have 2 cells. Which is the code here, that defines the code. There are observables. I won't go through this code too much in depth, but it's fun to play around with. I can share it afterwards. And the main thing is you have this observable context where we put all the variables. And as I now change one cell, you see the console.log actually is the code of the other cell that automatically executes. So I thought this was a fun exercise to see how you can implement a basic system like this. It definitely has some pros and cons. So I think, okay, what you saw, a relatively simple implementation. It supports all pure TypeScript, JavaScript, so there's no custom language constructs. I didn't write my own compiler, write my own language, or whatsoever, and that's also great for interoperability. And it's fairly easy to reason about while coding. So this reactivity layer, if you create a button and you want to mutate a variable, you just say, okay, x++. I think that's easy when you're writing. So in that sense, it makes programming simpler. But it also has a lot of a bunch of cons. So there's no unidirectional data flow. So your program can end up in a state that is definitely more complicated to understand it completely what is happening if you start mutating variables from all kinds of different places. There's also a possibility for loops, although those are mostly detectable. I want to take a moment to put TypeCell in context to related work. And this is actually a slide from a blog from Thomas, who just presented. And he's talking about how you can have different substrates of interaction. And I think that is a really key concept that I'm inspired by. So if you look at Excel or spreadsheet software, I think the easiest substrate to interact with the software is just entering a bunch of numbers in the table, just editing a grid whatsoever. Then if you go one level deeper, you can start adding formulas, add equations. And if you go one level deeper, you can create VBA macros, although that is in a slightly different environment than the spreadsheet itself. But you can, you have these gradual modes of extensibility, and all the way at the top are the developers of the spreadsheet software if you have access to the source code. Let's have a look at what these different levels look like in TypeCell. So look at the gradual complexity. To make sure I'm somewhat on time, I pre-recorded this, but I'll walk you through this. So when you have something like Notion, you can't. There is no concept of a map, for example, right? Well, in TypeCell, because you have this live programming environment, you can import a mapping library from npm and add the concept of a map to the system. So here you see a document where we start creating the map. It uses map libre. And as I go down, there you see, okay, by creating custom code, we can create this map component. And the variables at the top, there's the two-directional data binding, so they live update as I interact with the map. Now this is all great, but you can't imagine, like, not every user is going to code these kind of things. So the next level of extensibility of that complexity is to reuse existing components. You couldn't do that by you can import the document that defines the map, and now this user with a little bit of code can add the map to his document. But still, it's possible to interact with it. Now, that still required a couple of lines of code, right, to get this, to import that map component. So what I actually want to achieve is really extensibility of the system itself. And we do that here by importing the other document as a plugin. Now this is done via code, but ideally this should be done via an interface, like a plugin store or whatsoever. And then in the other document, it says register block, a map with, by using this variable. And now the environment is actually extended as the user types / the map appears in the menu, and he can start editing it to the document. So now you can really extend the software that you're using from the software itself. And it's still possible to program against it. So here I can use code to update the zoom level, or I can use code to inspect it. And this updates as the user interacts with the map. Now this is nice, but imagine that I want to create a document where that I want to share with others, saying, okay, this is the location of the conference. Then we still have an issue because, okay, now I can add an interactive depth map to my document, but it's not really, as soon as I refresh, that state is gone, right? So now how do we go about persisting the state in a user-friendly way? Of course, I could do this by setting the latitude via code, set the latitude, the longitude, the zoom level, but then that would still require code from the end user. So if we want to go one level further into the gradual extensibility, we can look into, okay, how can we provide a sort of a no-code customization experience. And the thing that I'm exploring is just, okay, by specifying the properties that should be configurable. Now when the user adds the map, a settings panel also appears, and he can use that settings panel to, without any code, really set some of the key properties that he might be interested in. Now, entering a location by entering the latitude and longitude is still not very user-friendly, so what we do here is you can copy the current variables, and now it's set to those, and as the user refreshes, those are persisted as properties of the map component. And now we have this page that can be shareable with kind of like a no-code experience. You can still program against it, so here you can create more advanced data bindings, and instead of a value, I bind a piece of code to it, so I bind the value of the slider that I just created, so that's also possible. All right. So that explores the different levels of gradual extensibility in TypeCell. If you compare it to other software, I think this was useful. If you see Jupyter or Observable or notebook-style software, they quite focus on programmers, on engineers, right? So they focus on that harder substrate, which is Python or custom JavaScript in the case of Observable. Then you have Spreadsheets, which do have a really easy substrate, grids. Coda more has like this rich text document editing as the easiest substrate. Then you can go one level deeper with formulas, but you can't really go all the way down to the programming environment, right? So with TypeCell, I'm exploring, okay, can we create something that spans all these, really goes from the easiest to the hardest substrate. I'm doing this by focusing on these key points. So there's a focus on liveness. As you see, everything executes client-side in the browser. It evaluates as I type. Things are live and composable, and we try to retain that liveness across documents. The environment is extensible, so whereas previously you didn't have the notion of a map component, I can extend the environment to add that. Two other things that I would like to show. It's more experimental, but because all the code can be written in TypeCell, in TypeScript, sorry, we can use the type system to create new experiences, and also see where we can get with when we further combine documents and code. Let's start with the letter. This one was very much inspired by Jeffrey's talk after me, so about Embark, and I tried to see, okay, can I replicate somewhat of that experience in TypeCell? It's definitely some differences in the approach, and the UX that you see here is not ideal yet, but it does show the potential of going about this. So we can actually write code that inspects the document that I'm editing. So what we're doing here is kind of like Inception style, is see, okay, output the value of the block as I'm editing it. It's also possible, okay, let's say first block, and now as I edit the title of the document, you also see this variable being changed. And yeah, then you can start coding with that variable. So this is the Embark inspired use case, where let's say you're planning a road trip. I'm trying to establish a context from what the user is creating in the document. You see these inline code cells, definitely not the prettiest, but they help to add context that we can then program against. Here are some API calls for routing, for geocoding. And what you see is, okay, 2 locations, and as I edit the location, the coordinates automatically update. And then at the, so you see that it's done by doing the geo lookup. And then at the higher level, there's this piece of code which, based on, in the bullet list, you see the column separated property name, property value, and it parses that. And the parsing of that is actually also not written, it's not part of the TypeCell source code. It's one of the blocks below. There is this concept of like a smart block, which just says, okay, parse the children. So this parsing, where you see as I edit the greeting, that this variable updates, that is something that was thought of in the context of this document. But then if we build upon that, I can also add a map, and I can start plotting the route on this map, so you get this interactivity between code and the document. Now you see the route being plotted, and we retain the liveness as I change the destination. So copy paste, add a new destination. Let's say I want to go to Spain. There was a typo there, but you can see everything updated as I type. So now I go to Madrid, and even as I drag and drop, it will change the order, because like the way the query is built, it will query from top to bottom. And now you see, okay, going to make a large detour by first going to Madrid, or actually here I can edit it to Barcelona and go there first, etc. So this is an early experiment of how all these systems can interact. Finally, another early experiment that I did, and I think we were talking about this earlier in the LLM talk, talking about formal and informal types of data. Because we have the document text, yeah, that's very much, it is somewhat structured, especially in the block, because we work with blocks. So the previous road trip example showed, okay, how can we use the structure of the document to extract context? I also try to explore, okay, can we use an LLM to extract unstructured or more difficult structured data from the document? So in this, see full screen, not sure if you can read it yet, but it basically says we're planning to build offices in Amsterdam, Berlin, San Francisco, and we're not planning to build offices in Barcelona, Prague. Super simple example, but we can feed that data to an LLM. But what we can also do is feed it the context of the code. So now we ask LLM, show office locations on the map. And we also give it the information of that map component. And we do this by providing it the TypeScript types. And in the map component, there's this type markers, which is an array of marker objects which take a latitude and a longitude. And we pass this TypeScript definition of everything that is in context, so including that marker property, to an LLM. And it then figures out, of course, 8 out of 10 times. And there's a long wait here. But then finally it figures it out, starts typing in the document, and you can start collaborating with the LLM, and it starts, and then it adds these locations to the map, and it only adds the ones where we're actually trying to build offices. Can zoom in, explore Berlin, Amsterdam, San Francisco. And I think that is also quite promising on how you can reuse the type system for extensibility like this. All right. Definitely also some challenges and things I'd like to explore further. Because we're in this notebook environment, sometimes like the state of what is executing on your local computer, right? So it's not it's happening in your browser, in your JavaScript environment. So you can interact with the document, and those interactions are not necessarily shared with other users. So sometimes it can get complicated, and what is the ephemeral, what's the local state layer, and what is the persistent layer? So the code in the document is persistent, but what do you want to execute locally, and what do you want to keep shared? I think it makes sense to have some things locally, but for example, in spreadsheets, like 90% of the stuff is shared, so it's easier to reason about for users. Same thing what I already discussed, mutability, side effects. I think it makes it easy to write code, but it can make it more challenging to read code. I think for small composable documents it can be suitable, but I think this is interesting to explore further. And then the last two demos, of course, super early work. I think it's there are some promising concepts of the gradual complexity, and okay, we can do a lot with the system, but I think a challenge will be, okay, what are the best primitives in terms of UX that we should provide to the user to make it prevent it from being necessary to dive into a code editor all the time. So we don't want those code snippets to show up inline. For example, can some things be handled in a no-code configurable way? I think that will it's promising to see this is possible, but getting the UX right will definitely take some research. Similarly to how we use the type system to empower the LLM, what I think is also really interesting, if we can use the type system as kind of like a material to weave together different plugins. So you saw, okay, we can create a plugin that defines a map, but maybe we can also create a plugin that defines if you have a type with a latitude and longitude, then you can modify that type with this plugin. And the plugin could be, so for example, this. Now it's nice, you can enter the number, but it would have been nicer if somebody else could create a plugin and you get this composable system, and one plugin could be, okay, you can select a location on the map, or another plugin could be, okay, you can do a geocode search for a specific location and then enter that location. And then hopefully the type system can be an interesting way to compose these plugins together. And this is very much inspired by Livelits and Hazel, and I think they explore that concept further, but I'd love to see how far we can push that. All right, thanks. It is online, it's open source. You can sign up and try it out. Would love your feedback, and also if you're interested in collaborating in some sort of way, also open for that. Would love to hear more, so hit me up the next couple of days. Thanks.
I think just maybe one or two questions so we don't get too far off time.
All right.
Well, there's someone else with their hand up behind you.
Okay, so who wants to go first?
Mine's going to be really short, I promise. That was very cool. So you've got the code blocks in the like Notion style, thingamajigama. And then you showed an example where it's like, I'm using some this thing colon that thing, and I'm reading it into the code block and doing some stuff with that. Have you ever played with like just throwing an eval in there and then writing your code in the nicely rich text side of the picture instead of this like terrible colorful monospace font world?
Yeah, you could. So basically, saying, you want to write the code here, right?
Yes, write the code there, and then just in one of the places where it's like, I can read stuff out of blocks. It's like, well, just put eval around it.
haven't tried that yet because like the block API just built. We could try it right now, but I heard we're short on the.
Okay, so there was a second part of that question, which is like, okay, of course, obviously you've done that because it's like,
Let's see.
obviously. Then how do you choose when to write in the little, formatted monospace gross world versus in the nice, like, typographic beautiful world? But that's,
I think the reason, like, for that monospace world is, because you do enter sort of a programming environment and you get all the Monaco benefits, right? So that's definitely, like, at least to me, that is a benefit, and you can get the auto-completion, etc. And they are, the way I think it should be, it's that they are collapsible, or you can present it in different ways. So now, by default, it outputs all the stuff that I export, but I can also say, okay, add a default export, which kind of overrides what it looks like. And if I combine that with collapsing it, you kind of get rid of that code experience, right? Because I do not imagine that you want to be sharing all these documents and just have code visible there for everybody. So either it should be part of a separate document, or it should be hideable, etc. I'm not sure yet about writing the code in the eval.
I'll argue with you about that, but later.
Okay.
Yeah.
All right.
Here we can give it a shot. Just I hope thing will not explode, but let's say.
All right, while Yousef is doing that, I will introduce Paul Sonntag, my colleague at Ink and Switch, who's presenting the Embark paper. I have been following this work for quite some time, since we did it at the lab. Hey! It worked, but you were so busy figuring out if you could, you never stopped to ask if you should. So thank you, Yousef. Let's give him a round of applause.